Okay, so welcome back to another IGCSE session. Basically today what we're going to be covering is we're just going to be covering, this is going to be a really quick video. It's going to just be talking a little bit about soil acidity. So if you were to look into your syllabus, which is your guide, your syllabus here, right, is one of the, you know, parts of chapter 8.1. We need to be able to describe the importance in controlling the acidity in soil. And basically this is how to neutralize soil based off of, human activities. So basically what this unit needs to talk about is that soil acidity is increased, or soil acidity is increased. So we'll say pH is decreased, or soil acidity is increased, and these are due to basically natural processes, or as a byproduct of human activities, So it can come as a byproduct, right? We're not going out and just taking our big jug of HCl and dumping it into the soil. It's not a direct product of our activities. It's a byproduct. So it's a byproduct of the combustion of fossil fuels, a byproduct of farming and fertilizers, yeah, and also as natural processes. So the soil acidity can increase based off of acid rain. So this is in like a high pollution environment. This is high air pollution, because acid rain is caused, from combustion in internal combustion engines. So where there's more cars, it's more acid rain, and also it's from coal-fired power plants, because contained in coal is sulfur. So we can write that in two different ways. Either way, is the American or British way. So contained in coal, there's sulfur contained in coal. So when we burn it, we release sulfur dioxide, which reacts in our atmosphere to create acid rain, or to acidify the water moisture in air. Two, and this is kind of from from natural fertilizers, from natural fertilizers, because what occurs, right, is that bacteria and fungi, it decomposes natural rotting material, and as a byproduct, of this, breakdown of natural materials, we have an acid. Acid is produced as a byproduct. So acid is produced as a byproduct of a natural process. Soils with large amounts of dead organic matter, natural rotting material. Another way we can say is dead organic matter. So it tends to be more acidic. And then finally, so the use of let's change this, use of synthetic fertilizers. So use of synthetic fertilizers, because right, we studied the ammonia process. NH3 reacts with H2O to become NH4 plus and OH minus. We can write that also as NH4OH. I just wanted to write it separately to show that that we you know, this process right here is a reversible process. So basically, here it acts as a base, and here it acts as it donates H plus. And in a lot of our fertilizers, let me just scroll down a little bit. In a lot of our fertilizers, we've got a chemical called NH4NO3, ammonium nitrate. And although it's a weak acid, it's still an acid. It still liberates H plus into the soil. So as we all know, right, plants require three different primary components, three primary components of fertilizers, and those are N, P, K, and those are the elemental forms, so how they're written on the periodic table: nitrogen, phosphorus, and potassium. And plants need these for abundance of different reasons, but the most important one is nitrogen. So that's why we use fertilizers like NH4NO3, because we see it's got lots of nitrogen. It contains lots of nitrogen in it, and this helps plants produce chlorophyll. Plants produce chlorophyll, which is required, and chlorophyll is needed for photosynthesis and healthy growth. So you can see, one thing leads to another, leads to the production of chlorophyll, and chlorophyll, plants need chlorophyll in order to grow healthily. So let's look at really quickly. I thought I couldn't go any more left there. Okay. So let's look at really quickly this extra diagram that I found. Is that if you look right here, this is in acidic soil, and this is in a soil that's pH is tailored towards the optimal pH of the plant. So you can see, 1 pH difference, a 10 times difference in concentration, greatly affects the root growth of plants, and plants require roots. So plants require their roots. So through the roots, through roots, plants uptake minerals and water. Plants absorb minerals and water. So right, in improper, so in high pH or high H plus concentration soil, plants tend to have poor root growth, which can also, if you look at a plant, right, if you've got a rather heavy plant, and you've got one with very, very shallow roots, and you take another heavy plant, I can't draw these the same size, but I'd like to, with really deep and extensive roots, one has a greater access to minerals under the soil, and the other one has a smaller surface area to access to the minerals under the soil. And also, right, we get a big gust of wind, blowing from the right here. This one's going to be planted into the ground a lot harder. This one's going to be more resilient to environmental changes. and this one's not going to be at all, right? This tree is going to be the first to fall down in a high wind environment, and this one's going to stay well planted. So basically, alls I want to cover now is that we use chemistry. We use chemistry to neutralize. Another way to say neutralize in this case, it wouldn't just be neutralized because we don't necessarily need it to be a pH of 7. Different plants grow better in different pH conditions. So some plants need a grow optimally in a pH of 6, maybe some in a pH of 5, maybe some in a pH of 9. So it depends on what crop you're growing to what we want to balance the pH to. But we use chemistry to neutralize it, and how we do that is through those reactions that we saw before, right? We saw the reactions both of an acid, so I'm not going to draw the counter ions, but these all have counter ions. It could be an H plus, it can be like a dilute nitric acid, but I'm not going to draw the nitrate ion. So H plus reacts with calcium carbonate, and another word for calcium carbonate is limestone. So it's another natural product. So it reacts with limestone, and limestone, this CO3 means that it's a carbonate. This is what we did in one of the last videos. H plus reacts with carbonates in order to neutralize. So basically we release CO2, we release H2O, and we're going to have Ca calcium 2 plus ions instead. So the H plus is going to basically get converted through a chemical reaction to liberate H2O. And H2O is not bad for the environment at all, right? So basically we can neutralize the acidic soils. So let me just try to balance this off a little bit. There you go. So O3, O3, H2, H2, C, and Ca2 plus. Good. So we can add limestone directly to the soil, and we till it into the soil, so we basically dig it into the soil, and when it rains they react together. Or what we can do is we can take calcium carbonate, we thermally decompose it. I'll change colors for that. So this is thermal decomposition, and it thermally decomposes to calcium oxide and CO2. And then we can use this. This is what we're going to do in the next lesson, is that what we're going to see is that metal oxides are basic, and non-metal oxides are acidic. So we're going to see that next lesson. So this is a metal oxide, right? So iron oxide, copper oxide, magnesium oxide, lithium oxide. These are all metal oxides, and these are all basic. And as we know from the last lesson, right, an acid plus a base, they undergo a reaction called neutralization, and they create a salt and water. So if you haven't watched those last videos yet, you need to watch them in order to go over this unit. So what we can use to neutralize the soil, like I said, we can use calcium carbonate, we can use calcium oxide, or we can react calcium oxide, we can react it with water in order to form calcium hydroxide. And as a hydroxide, this is a base. And as a base, it can neutralize acids. So I hope that this made some sense, and why it's important to neutralize acidic soils. Like I said, plants with a highly acidic soil have trouble absorbing nutrients from the environment, and they have trouble planting themselves in the ground. So there's multiple issues with this. So okay, so that's the end of this video, and I will see you in the next one.